everyone, myself Ajay Priya from Sacred Art College. Today we are going to see about microbially induced corrosion. First, we are going to see about what is an corrosion. It is a physico-chemical interaction between a metallic material and its environment can lead to corrosion. Then we are moved to microbially induced corrosion. It is an activity of microorganism within the biofilms formed on the surface of metallic materials. It can affect the kinetics of cathode or anode reaction, and then it can also considerably modify the chemistry of any protective layers, and then leading to either acceleration or inhibition of corrosion. Then we will move to microbial corrosion. This microbial corrosion, also called as a microbiologically influenced corrosion or biocorrosion. This biocorrosion is an corrosion affected by the presence or activity of microorganism in biofilms on the surface of the corroding material. This corroding material can be either a metal such as steel or aluminum, or a non-metal like concrete or glasses. Prerequisite for the MIC is the presence of microorganisms. If the corrosion is influenced by their activity, for the requirements or an energy source, carbon source, electron donor, and electron acceptor, finally, and water. A role of MAC is often ignored if an abiotic mechanism can be invoked to explain observed corrosion. What causes the microbially induced corrosion? Yes, absolutely. Microorganism can cause the MIC. There are microalgae, bacteria, or fungi can cause the microbiologically influenced corrosion. Although they do not produce a unique type of corrosion, they can speed corrosion reaction or influence the mechanism of corrosion. This image shows the normal corrosion and microbial corrosion. Corrosion is an electrochemical condition in metal is converted to stable forms, example sulfide, hydroxide, oxide. In microbial corrosion, it facilitated by microorganisms like bacteria, fungi, and algae. The biofilm or gel formation on the corroding material. The metal biodeterioration, that is biomass or biofilm or exopolysaccharides. These are some images to show the microbiologically induced corrosion on corroding material. Where does the microbial corrosion occurs? Microbial corrosion occurred in various environments like seawater, freshwater, soil, foodstuff, demineralized water, sewage, aircraft, petrol, human plasma, and process of chemicals. This means it is a potential concern for a vast range of industries. These microbes can influence the corrosion through their metabolic process like sulfate reduction, sulfur oxidation, ion oxidation or ion reduction, formation of exopolysaccharide, and finally cathode depolarization through the hydrogen utilization. In mostly sulfur reducing bacteria are one of the most predominant types of bacteria associated with the MIC. In the absence of oxygen or low oxygen condition, sulfate reducing bacteria converts the sulfate ions and sulfides and can corrode metals through a series of oxidation and reduction process. In the same way, sulfide oxidizing is occurred by sulfide oxidizing bacteria. The first step is anaerobic step. It occurs the sulfur reducing bacteria reduces the sulfate and other microorganisms oxidize the sulfur compounds to hydrogen sulfides. This hydrogen sulfide volatiles the and dissolve in the molecular concrete surface. And finally, ion oxidation. Ion oxidation is carried out by ion oxidizing bacteria. It can be oxidize the ferrous ions to ferric states to obtain their energy. For example, the deposit of ferric oxide on carbon steel pipeline surfaces and the promote tubercle formation. And then we are moved to microorganisms implicated in MIC of metals such as iron, copper, and aluminum, and their alloys are physiologically diverse. Bacteria involved in metal corrosion have frequently been grouped by their metabolic demand for different respiratory substrates or electron acceptors. The capability of many bacteria to substitute oxygen with alternative oxidizable compounds as terminal electron acceptor in respiration When the oxygen becomes the depleted in the environment, permits them to be active over a wide range of conditions conductive for a corrosion of metals. The ability of produce wide spectrum of corrosive metabolic byproducts over a wide range of environmental conditions makes the microorganism to a real threat to the stability of metals that have been engineered for the corrosion resistance. Finally, how to detect the MIC? The microbially induced corrosion was detected by three broad categories. That is, first one is surface inspection, and second one is microbial sampling and identification of microbes, and finally corrosion rate determination. Thank you for all watching and listening my video. Thank you.